Hey guys, today we're going to work on a little mini lesson for simple and compound interest. So we're going to start with the formula for simple interest. It's written as A equals P times the parentheses 1 plus RT. And so in this formula, P is going to represent what we call the principal, which is the starting amount. So when we're talking about interest, we're referring to bank accounts, and the interest is the amount of money that the bank pays you to keep your money with them at that bank. So the starting amount is typically what you are going to deposit into the bank account, and we call that the principal. R is going to be your rate. That's your interest rate, and we write that as a decimal. And then T is going to be your time in years that you have your money at the bank without touching it. Now this is different from compound interest. So the formula for compound interest is A equals P times parentheses 1 plus R raised to the T power. So you can see that all of our same variables are in here. So P is still going to represent the principal, or the starting amount. Again, the amount that you are depositing. 1 is always going to be in here for both of these formulas. Again, this is always 1. R is going to be your rate as a decimal. And then T is your time in years. And so the difference here is that our compound interest has an exponent while the simple interest formula does not. Let's look at an example. So in my example, we have Nico, who deposits $500 in a simple interest account. And that account earns 5% interest. So our account being a simple interest account tells me which formula we want to use. Let's go ahead and make a table to fill out so that we can see what's happening here. Okay. So to fill out our table, the X column is going to be our time in years, and then the Y column is going to be our account balance, and that's going to be in dollars. So we're going to look at the years 0, 1, 2, 5, and 10. So at 0 years, right at the very beginning, Nico starts with $500. That's how much he has to put in his account. Now, after 1 year, I want to use this formula up here to figure out what it's going to be. So we have to start with our principal, which is our starting amount. It said that he deposited $500. So that is my starting amount. And then my formula tells me that it's parentheses 1 plus. So I've got parentheses 1 plus. My rate was 5%. but we write that as a decimal. And so 5% written as a decimal is 0.05. So when I put it down here, I'm just going to put 0.05. And then my time in years is going to be right here, and this is going to be after 1 year, so I'm going to write times 1. Close that parentheses. And so now I'm going to grab my calculator, and I'm going to put this into my calculator because that's the easiest way to do this. So let me grab that right here, and I'm going to put it in exactly how I see it. So 500 parentheses 1 plus 0.05 times 1 close parentheses. Right, so you can see that this is written the exact same way as the expression, and I'll press enter. And after 1 year, Nico has $525 in his account. Now we can go ahead and put the same thing in now for year 2. So I could write it out. It's going to be 500 times 1 plus 0.05 times, and now the year is 2. So if I put that in my calculator here, 500 times 1 plus 0.05 times 2, close parentheses, I end up with $550 that Nico has in his account. Now for my next one, I want to know how much after 5 years, so I'm just going to go back to my calculator and put this all back in, multiply it by 5 now. And so after 5 years, he's up to $625. And then after 10 years, he has $750. So we can see here that this 0 to 1 to 2 is just adding $25 each time. And so the thing that I want you to remember is that simple interest is adding the same amount. I'm going to put AMT, amount each year. So simple interest is linear, which hopefully you could have noticed from the formula. Okay, let's look at a compound interest example. So we're going to have Maya, who is also depositing $500, but she's doing it in a compound interest account. And her account is earning 5% interest annually. So let's go ahead and make the same table for her. I want us to be able to compare how these two types of interest are different over the same amount of time with the same percent interest and the same deposit. So 0, 1, 2, 5, and 10 here. And we're going to fill this in. So we know that at 0 years, at the very beginning, she is depositing the same amount. So she's starting with 500. Now let's set up our compound interest formula. So that tells me that I put my interest first, or my principal first. My starting amount is 500, parentheses 1 plus my rate as a decimal. Well, it's the same rate, so it's 0.05. Now I close that, and then the 1 here for time goes in the exponent. So I'm going to grab my calculator and do that really quick. And then raise to the first power. And I get that. After 1 year, Maya also has $525 in her account. So for 1 year, it doesn't actually matter which type of interest we have. But let's look at what happens for 2. I'm going to write it out again for you just so that you have it. So 500 parentheses 1 plus 0.05 and now raised to the 2 power, or second power, excuse me. So I'm going to put that in 500 parentheses 1 plus 0.05 close parentheses raised to the second. And so after 2 years, Maya has $551.25. Compared to Nico had $550 after 2 years. Maya has $551.25. So she has slightly more, but it's not a very big difference. Let's go ahead and look in our calculator to see how much Maya will have after 5 years. So I put that in my calculator, and I'm going to round to the nearest hundredths because we're dealing with money. So we want to have 2 numbers after our decimal place because that's the proper way to write money. So I'm going to round this to $638.14. So compared to Nico's 625, we can see that they are starting to grow apart a little bit faster. And now for 10 years. Maya, after 10 years, will have $814.45. And so the thing that you need to remember about compound interest this one is multiplying. So where simple interest is adding the same amount, compound interest is multiplying by the same amount every single time. Where simple interest is linear, compound interest is exponential. And so the more money that you put into your account and or the higher your interest rate is, the more that these two values will grow apart. In the long run, a compound interest account is way better to have over a long length of time than a simple interest account. The majority of savings accounts that are out there for your banks, so I would say with 99% certainty that if you have a savings account already or you are going to have one, it will be a compound interest account.